This topic is about refrigerants. Refrigerants is the primary working fluid used for absorbing and transmitting heat in a refrigeration system. Refrigerants absorb heat at a low temperature and low pressure and release heat at a higher temperature and pressure. Most refrigerants undergo phase changes during heat absorption, evaporation, and heat releasing condensation. So these are the types of refrigerants. Later, discuss natin yan. Number R32, R125, R134A, R407B, so on. Okay. Next is the cooling medium. The cooling medium is the working fluid cooled by the refrigerant to transport the cooling effect between the central plant and remote cooling units and terminal. In a large centralized system, it is often more economical to use a coolant medium that can be packed to remote locations where cooling is required. Chilled water, brine, and glycol are used as cooling media in many refrigeration systems. The cooling medium is often called a secondary refrigerant because it obviates extensive circulation of the primary refrigerant in mga long distance. Tignan nyo lang yung video. Later tayo discuss yan. So, liquid absorbent. A solution known as liquid absorbent is often used to absorb the vaporized refrigerant, water vapor, after its evaporation in an absorption refrigeration system. So, discuss natin yung absorption later. One topic. This solution containing the absorbed vapor is then heated at high pressure. The refrigerant vaporizes and the solution is restored to its original concentration for reuse. Lithium bromide and ammonia, both in water solution, are the liquid absorbents used most often in absorption refrigerating system. This is one type of refrigerant absorption. There are evaporator, generator, condenser, expansion valve, and absorber. So later na yung discussion. Azeotropic, azeotropic, and zeotropic. A refrigerant can either be a single chemical compound or a mixture blend of multiple compounds. Yan mga type. Azeotropic. These are blends of multiple components of volatilities, refrigerant, that evaporate and condense as a single substance and do not change their volumetric composition or saturation temperature when they evaporate or condense at a constant pressure. Components in a mixture of azeotropes cannot be separated from their constituent by distillation. Properties of azeotropic refrigerants are entirely different from those of their component and may be conveniently treated as a single chemical compound. This is one type of azeotropic, R507. Near-azeotropic. Near-azeotropic refrigerants are blends whose characteristics are near to azeotropic, although properties of near-azeotropics are nearer to azeotropic than to non-azeotropic or zeotropic. Near-azeotropic refrigerants are defined as zeotropic or non-azeotropic. So ito yung example, Freon R410A. Azeotropic. These are blends of multiple components of volatilities refrigerant that evaporate and condense as a single substance and do change volumetric composition or saturation temperature when they evaporate or condense at a constant pressure. So this is the example, refrigerant R407C. Blends. Blends define the mixture of refrigerants of two or more chemical compounds are called blends. The advantage of a blend of multiple chemical compounds compared to a single compound is that the required properties of the blend can possibly be achieved by varying the fractional composition of the component. The A and B like mix, so line. So the difference in dew point and bubble point in a temperature concentration of azeotropic refrigerant during evaporation and condensation is called light, expressed in the Fahrenheit or C, degree C. A near azeotropic refrigerant has a smaller light than azeotropic one. The midpoint between the dew point and the bubble point is usually taken as the evaporating or condensing temperature for non-azeotropic and near azeotropic refrigerant. Ideal or perfect azeotropic refrigerants are uncommon, whereas near azeotropic ones are fairly common. Numbering of refrigerant. So, because of the complexity of this name, especially the CFC, the fully halogenated CFCs and hydrofluorocarbons CFCs, the not fully halogenated CFCs, see figure 1, a numbering system was developed for hydrocarbon and halocarbon and is used widely in the refrigeration industry. According to ANSI ASTRI standard 34-97, the first digit from the right is the number of chlorine atoms in the compound. Like this one. 2. Chlorine is a water flow, so we have 3. Like that. So the second digit from the right is 1 more than the number of hydrogen atoms in the compound. Dalawa, H is lactose plus 1, 2. Ya, itu yang numbering, itu yang chemical. So itu 0 yung hydrogen plus 1 is 1. Okay. The third digit from the right is 1 less than the number of carbon atoms in the compound. So the third, so wala siyang third kasi carbon is a minus 1, so wala. Okay, dito may isang carbon. So minus 1 din. If the digit is 0, it is omitted from the number. The fourth digit from the right is the number of unsaturated carbon-carbon bonds in the compound. The digit is 0, it is also omitted from the number. For example, the chemical formula for of HCFC123 is CHCl2 CF3. There are 3 fluorine atoms in F. First digit from the right is 3. There is 1 hydrogen. So, second digit from the right is 1 plus 1 or 2. Yeah, 2. There are 2 carbon atoms. Third digit from the right is 2 minus 1 is 1. No unsaturated CC bonds. The fourth digit from the right is 0, so omitted. Properties and characteristics of the refrigerants. So today, the preservation of the ozone layer is the first priority of refrigerant selection. In addition, the global warming effect and the following factors should be considered. Safety requirements. So refrigerant may leak from pipe joints, seals, or component parts during installation, operation, or accident. So therefore, refrigerant might be acceptably safe for humans and manufacturing processes with little or no toxicity or flammability. A refrigerant safety classification is its combination of toxicity and flammability. According to ANSI ASTRI Standard 34-1997, safety groups are classified as follows. So A1 means lower toxicity and no flame propagation. A2, lower toxicity and lower flammability. A3, lower toxicity and higher flammability. And B1, higher toxicity and no flame propagation. B2 is higher toxicity and lower probability. B3 is the higher toxicity and higher probability. Next is the effectiveness of refrigeration cycle. The mga characteristic. The effectiveness of refrigeration cycles or coefficient of performance, COP, is one parameter that affects the efficiency and energy consumption of the refrigeration system. The COP of a refrigeration cycle is using a specific refrigerant depends mainly upon the azeotropic work input to the compressor at a given condensing and evaporating pressure differential, as well as the refrigeration effect produced. This case of C is also COP. Next is the evaporating and condensing pressure. It is best to use a refrigerant whose evaporating pressure is higher than that of the atmosphere, so that air and other condensable gases will not leak into the system. Napalabas niya. And increase the condensing pressure. The condensing pressure should be low because the higher condensing pressure necessitates severe construction of the compressor, piping, condenser, and other components. In addition, a high-speed centrifugal compressor may be required to produce a high condensing pressure. Next characteristic is the oil miscibility. When a small amount of oil is mixed with refrigerant, the mixture helps to lubricate the moving parts of a compressor. Oil should be returned to the compressor from the condenser, evaporator, accessories, and piping in order to provide continuous lubrication. On the other hand, refrigerant can dilute oil, weakening its lubricating effect, and when the oil adheres to the tubes in the evaporator or condenser, it forms film that reduces the rate of heat transfer. Inertness. An inert refrigerant does not react chemically with other materials, thus avoiding corrosion, erosion, or damage to the components in the refrigerant circuit. Next, thermal conductivity, which is of a refrigerant, is closely related to the efficiency of heat transfer in the evaporator and condenser of a refrigeration system. Refrigerant always has a lower thermal conductivity in its vapor state than in its liquid state. Higher thermal conductivity results in higher thermal heat transfer in heat exchanger. Refrigerating capacity. The cubic feet per minute CFM suction vapor of refrigerant required to produce 1 ton of refrigeration or liter per second to produce 1 kilowatt of refrigeration depends mainly on the latent heat of vaporization of the refrigerant and the specific volume at the suction pressure. It directly affects the size of and compactness of the compressor and is one of the criteria for refrigerant selection. Next, physical properties. Discharge temperature. A discharge temperature lower than 200 Fahrenheit or 100 C is preferable because temperatures higher than 300 Fahrenheit or 150 C may carbonize lubricating oil or damage some of the component. The electric properties are important for those refrigerants that will be in direct contact with the windings of the motor, such as refrigerant used to cool the motor winding, hermetically sealed compressor, and motor assembly. Operating characteristic. Refrigerant leakage should be easily detected. If it is not, gradual capacity reduction and eventual failure to provide the required cooling will result. Most of the currently used refrigerant are colorless and odorless. Di mo makita, di mo maamoy. So, di mo maamoy, di mo makita. Next is the phase out of ozone depletion refrigerant. Diba po yung phase out na. So, to compare the relative ozone depletion caused by biorefrigerant, an index called the ozone depletion potential, ODP, has been proposed. ODP is the rate of ozone depletion of 1 pound of any hydrocarbon to that 1 pound of CFC level. The ODP of CFC level is assigned as value of 1. Okay. The following are ODP values for various refrigerant. The refrigerant chemical formula, ODP value, andito siya. Ayan. Matataas, CFC. Ito yung alternative HFC. So ito yung uso ngayon. Zero yung ODP. Similar to ODP, the halocarbon global warming potential, SGWP, is the ratio of calculated warming for each unit mass of gas emitted to the calculated warming for a unit mass of reference gas. The SGWP of bulk refrigerant are listed in table 1. Dito siya. So natin na lang SGWP, yung ODP, ito. Yan, kung ano yung refrigerant, dito siya. Yung mga pinagbasihan ng value. Evaporating pressure, condensing pressure, compression ratio, refrigerant, and effect. So this is properties of commonly used refrigerant at 40 Fahrenheit, evaporating, and 100 Fahrenheit condensing. So saturation to 135.6, temperature na is 40. Sa refrigerant 32. Yang nanggaling niya. In addition to SGWP, another global warming index uses CO2 as a reference gas. For example, 1 pound of HFC22 has the same effect on global warming as 4,100 pounds, 1,860 kilograms of CO2 in the first 20 years after then it is released onto the atmosphere. Its impact drops to 1,500 pounds or 680 kilograms after 100 years. So ito pa yung properties. Ito yung alternatives, trade name, karapang pa ito. Yung power consumption. Yan. Kita niyo trade name, ito yung brand. Ito yung safety kanina, A1, A2, B1 kanina. So, in late November 1992, representatives of 93 nations meeting in Copenhagen also agreed to complete cessation of CFC production beginning January 1, 1996, and of halons by January 1, 1994, except contingent use from existing, reclaimed, or recycled stock in developed nations. In addition, the 1992 Copenhagen Amendments and later the 1995 Vienna meeting revision agreed to restrict the production of HFC relative to 1989 level beginning from 2004 in developed nation according to the following schedule. So this is the schedule. January 1, 1996, 100% capacity cap. Cap is 2.8% of ODP of CFC consumption plus total ODP of the 1999 CFC consumption. So 2004, 65% cap. So 2010, 25% cap. So HFC. 21-2030, complete cessation of production. CFC. Consumption indicates the production plus import minus export in feedstock. The value of 2.8% cap is the revised value of the Vienna meeting in 1995 to replace the original value of 3.1% in the Copenhagen Amendment. The Copenhagen Amendment has been ratified by 58 parties. Actions and measures. The impact of CFC on the ozone layer poses a serious threat to human survival. The following measures are essential. A. Conversions and replacement. Use alternative refrigerants, substitute to replace the CFCs in existing chillers and direct expansion DX chillers. During the conversion of the CFC to non-ozone replacement alternative refrigerant, careful analysis should be conducted of capacity, efficiency, or miscibility and compatibility with existing material after conversion. For many refrigerant systems that already have a service life of 4 more than 15 years, it may be cost effective to buy a new one using non-CFC refrigerant to replace the existing refrigeration package. So HFC 134A and HCFC 22 are alternative refrigerant to replace CFC 12. HCFC 123 and HFC 245CE are alternative refrigerant to replace CFC 11 in large helium. Then HFC 134A, SFC 407C, and SFC 410 are alternative refrigerant to replace HFC 22. SFC 407 is to replace HFC 22. SFC 407 is a near azeotropic refrigerant of SFC 32, SFC 125, SFC 134A, 23, 25, 52. Means 23%, 25%, 52%. And HFC 410A also near azeotropic refrigerant of HFC 32 and HFC 125 mix, so blend 50-50. SFC 245CA or another new FC possibly developed for 2004 will be the hopeful alternative to replace HCFC 123. In supermarkets, CFC 502 is a blend of HCFC 22 and CFC 115. It's made 48.2 and 51.2%. Then HFC 404A, HFC 507, and HFC 410A are alternative refrigerant to replace CFC 502. HFC 404A is a near azeotropic refrigerant of SFC 125 and SFC 143A and SFC 134A. That's 44, 52, and 4. And HFC 507 is an azeotropic refrigerant of SFC 125 and SFC 148. It's 45-55%. Avoid CFC and SCFC emission through recovery, recycle, and reclaiming. According to ASTE Guide 3-1990, so we have a siguro latest ito. Recovery is the removal of refrigerant from a system and storage in a sterile container. Recycle involves cleaning the refrigerant for reuse by means of oil separator and filter dryer. In reclamation, refrigerant is the process for new product specification. Next, specification of refrigerant. Hydrofluorocarbons. HFCs contain only hydrogen, chlorine, and carbon atom. They contain no chlorine atom, therefore are environmentally safe, cause no ozone depletion. They are designated by the prefix SFC. HFC 134A is an attractive long-term alternative to replace CFC 12 in reciprocating screw, and centrifugal compressor, and a long-term alternative for HCFC 22. It has a low 0.28 HGWP. HFC 134A is non-flammable, has an extremely low toxicity, and is classified as A1 in ANSI ASTRE standard 34/1997 safety rating. So next, HFC-245CE also does not contain chlorine and bromine atoms, and its ODP is 0. Compared to CFC11, its efficiency will be at 3 to 4% lower. The synthetic polyester lubricant oil will be used, except for neoprene at high moisture content. Common materials used in the refrigeration system were shown to be compatible with HFC-245CE and S. Smith et al. Reported that the mixture of HFC-245ACA in air with a relative humidity of 43% and a HFC-245 concentration range of 7 to 14.4% were observed to be flammable test. HFC-212CA is a possible long-term alternative to CFC-11 and CFC-123 in large and typical chiller temperature. The HFC group, SFC-32, SFC-125, HFC-143A, and HFC-152A are all seldom used as a refrigerant for single compartment. So this is the R245FA. Malapit na ito yung tago. So wala makisenteret na 245CA. Next, Azeotropic HFC. Yung HFC 507 is an azeotrope of refrigerant blends of HFC-125, HFC-123A, 45 to 55%, of zero ozone depletion and an HCWP of 0.96. It is a long-term alternative to replace CFC 502 and CFC 12 in low-temperature refrigeration systems. Post-evaporating temperatures are below 210 Fahrenheit to 212 C. HFC 507 needs synthetic lubricant according to ANSI as a standard 34-1997. HFC 507 is allowed alternative designation for HFC 507A, a higher refrigeration blend of HFC 125 and HFC 140A, or 50